Go.
Good afternoon, and welcome to Metro Home Theater Tech Tips. I'm Brent.
I'm Adam.
And pardon the momentary glitches and interruptions, we have a brand new video switching system with all sorts of fancy things that it can do, and we ain't doing it so well.
Brand new learning of things. So
yes, brand new learning curve. So, talk to me, Adam. What is today's class?
Well, today's class is really exciting because today we are talking about, let's see if I can get it to work, and there we go, HDMI cable deconstruction part 4.1.
4.1.
We are talking about TMDS. This is the fifth episode in a series of 6 where we are going to be talking about HDMI cable construction, and we are finally to the meat and potatoes of what we're talking about today.
I like meat and potatoes, especially when HDMI. It's rare to dead.
Rare to dead, right?
Rare to just basically dead.
Okay, there you go. So it literally just made its way off the slaughter floor.
You got it.
You're good with that. Okay. All right. So everybody, thank you for joining us for today. Like I said before, we're talking about HDMI and the deconstruction of HDMI as a cable itself and what it does. Today we are talking about HDMI TMDS lines. And Brent, what does TMDS stand for?
Well, it's interesting because I've been talking about TMDS for 14 years now.
Yep.
And it seems that every time I describe what TMDS is, I use 4 different words.
Yes. Yep.
So today we actually looked it up.
Yep. So you got the right words.
I got the correct words. And my typical is transmission minimized differential signaling or system.
Yep.
But the correct statement is transition minimized differential signaling.
There you go.
Now, what does this mean, Adam?
Well, it means lots of things. But before we go too far, we want you to talk about our sponsor, because
and our sponsor is
our sponsor today is the GA1.
Well,
This is the HDM-GA1. Great piece of technology. This has been out now for
5 years.
5 years now.
5 years.
This is a great piece. This will actually help you with HDMI 4K, or sorry, HDMI 2.0, in order to get a 24 gigabit signal. Now, granted, this is capable of 24 gigs.
Yes,
and
we will explain that in today's broadcast.
Yes, but so this will get you, this will ensure that you get an 18 gigabit signal where you need it to go on a passive HDMI cable of good quality.
Up to what length?
10 meters?
No.
Further than that?
Yes.
17.
Yes, and.
Yeah.
But that's not all.
Okay.
It will go typically 15 meters with pretty much any brand of cables.
Yeah.
With our MHX series, it will go 17 meters.
Wonderful.
With our VLOC series, it will go 20 meters at 24 gigabits.
Gotcha.
And that's 4 channels at 6 gigabits a channel. Now, we will describe that in much greater detail in today's video on TMDS.
Right. So, now, let's go back to what you were asking before. Everybody, thank you for checking in with us today. As always, if you have any questions or comments, or if you have any stories you want to tell us, or if you have something to talk about that even has nothing to do with what we're talking about today, please put it down in the chat section. If you were watching this after the fact and you have some questions or comments or anything you want to talk about, put it down in the comment section down below. As always, we do monitor all of that, so thank you very much. I do have some news. Our channel, we are now up to 960 subscribers.
So we need 40 more to break a grand.
Yeah, we need 40 more subscribers. So guys,
tell your friends, your neighbors, your daughters, your sons, your wife, your grandparents.
The extra Gmail accounts that you have, go ahead and sign into those and hit subscribe. I don't know. I did that for myself anyways. But do that for us because it helps out a lot.
Do you have extra accounts?
I have way too many accounts. It really helps out quite a bit, as always. Tony, it's great to see you. Thanks for stopping into the chat. Tony has actually asked us a question a couple weeks ago.
Okay.
And I apologize, I'm not remembering exactly which question it was, but they did. So we'll get on with that. But stick around for today. We've got some information about the CE world. We've got some news later on. And we have an ongoing tech call that we have not heard back from yet.
No, and this was
I'd like to talk about.
This is truly one of the strangest calls we've gotten in a long time. And there are certain manufacturers, every time somebody calls, like, really, we've never heard that one before. And you know you're the 10th call of the day with that question. Well, honestly, we've never heard this one before. Yeah. Tell us about it, Adam.
Well, we will. We're going to get to that. So now,
you're just teasing me.
I am. Yeah, I don't want to put it out there right now. We got to go through everything else first. Make them stick around for something a little bit more, right? All right. So everybody, we're going to go ahead and dive into TMDS, what it is, how it works, and we're going to talk about eye patterns today. Which we kind of touched on before a little bit. So we started talking about the transition minimized differential signaling.
Now, what does this mean to you in a traditional AV world environment?
No clue.
Okay.
I'll let you describe that one.
Wonderful. Well, first thing we're going to do is we're going to delete this out of there. And we wrote down what it says.
Wipes?
Yes. We wrote down what it says just in case the old man forgot what to call it.
Yep.
So transition minimized differential signaling is what we used to call XLR.
Okay.
It is a 3-conductor transmission system where you have an RX, a TX, and a ground.
Okay.
Now,
or positive negative ground?
No, RX, TX, and a ground. It's an AC waveform.
Okay.
So it's not really positive negative because the ground's separate. Now, what's the difference between a balanced and an unbalanced system?
You don't have a ground.
You don't have an independent ground.
That's what it is. Yes. Yes. It's sharing a ground with the ground.
Right. With the RX.
Which there was a fun story you told me a while back about the guy who used a single conductor for the positive of a speaker and literally used the earth as the negative.
Yeah, assuming that at both ends you've done that.
Yeah, which that's a fun story. Anyways, yes. So do you want to go ahead and...
Yes. So when you were looking at an HDMI transmission system, inside of the HDMI cable, would you give me the top-down shot
sure
there?
Will.
I'm going to move that up to the camera. There are 4 primary TMDS feeds: RGB and clock. Now, there is an extra color in here that's shielded. This is the EDID channels. So we're going to ignore that, but we've got RGB and clock. Now, the big thing that we're changing from where we were to where we're going is what these data channels are going to do, but let's talk about how they operate first. Each of these channels has 3 conductors in it, as we just discussed: RX, TX, and ground. Each of these channels transmits a data signal that is high bandwidth. Now, under the current rules, it's 6 gigabits per channel. RG and B, that's how we get to 18.
Right. 6 plus 6 plus 6.
Right. Now, when you're looking at this, and we just measure black because it's much more dynamic.
Yeah, there you go.
I'm going to create an eye pattern because this is how we test these things. An eye pattern is just how the scope looks at the signal.
Sure.
And it's an on and an off. For custom integrators, it's ramp time, it's rise time. It's the basics. So we have a 5 volt effectively and a 0.
Effectively.
A 1 and a 0, an on and an off, a yin and a yang, whatever you want to call it. So how we generate an eye pattern at high speeds is we're going to send a variety of different datas. Thank you.
Focus keeps running
So
out.
what we're going to do is we're going to, first off, we're going to send a 0, 0, 0. That just means it goes straight down the bottom.
Right.
Then we're going to send a 1, 1, 1. It's going to go straight down the top. Then we're going to send a 1, 0, 0, or 0, 1, 0. Then a 0, 1, 1, etc., all the way down till we cover all the different permutations of those numbers.
Sure.
Now, those numbers are going to wind up, depending on how good your transmission system is, looking something like this in their transition. So 0, 0, 0 just goes straight.
Right.
1, 1, 1 just goes straight. But let's say we have 0, 1, 0. It's going to look like that. Now we're going to do, for the simplicity of my drawing, we're going to do 1, 0, 1.
Right.
Which will be that. Now the reason this is called an eye pattern is because in the middle of these waveforms, there is a do not fly zone.
Yes.
And this do not fly zone is called a mask. This is why it's called an eye pattern, because it looks like an eye.
Yeah.
Not the letter I, but your eye. So the goal is to have the eye pattern, the waveform, be well outside of the mask.
Right.
The further outside of the mask it is, the greater the signal integrity.
Right.
Now, this is important because as the cable gets longer, this is a voltage swing. This is voltage driven. This is not current.
Right.
This is voltage driven. And anybody that's done DC lighting or any kind of DC signal knows that as you get further down the line, that voltage starts to drop and the transition time gets closer and closer to non-change. So I'm going to, I think we can see right here, yes we can. We're going to do a parallel run here. Over distance, voltage starts to drop. Over distance, voltage doesn't drop as far. So the two sections get closer and closer together to the point they
Draw that
breach
a little bit higher, Brent. They're not able to quite see that one. There you go.
We cheated.
There you go.
So doing this over distance, the signal starts to collapse. Both high and low start to come together.
Right.
And the reason for this is it just cannot make the transition. There's too much interference, there's too much friction.
Right. It can't get. It's not able to get that signal all the way across.
Right.
The experts actually made a comment for us.
Yes.
When I was talking about the positive wire and then using the earth as a common negative, they said it's a car stereo common ground.
Yes.
Way before my time is what he says. Way before your time,
fact,
Adam.
in my time, early audio box, for example.
Yep.
What you would have is a 3-pin DIN plug.
Yeah.
It had a left, a right, and a ground.
Yeah. Well, and they all shared that.
They all shared a common ground. So if you had 4 speakers, right front, right rear, one ground.
Yeah.
And GM did this for years. GM themselves would, in the early days when it was metal, they would actually ground the speaker to the vehicle.
Using the basket of the speaker itself?
Right, it would just screw to the metal portions of the speaker.
That's
but that's the old 12-volt days.
Right.
Then they came out with BTL, which is a floating ground, which meant you had to have an individual ground for each product.
So, I assume it's Mike over at the experts. I'm assuming. Hopefully, you understand what he's saying. You're right. That is long before my time. So.
Thank you. I appreciate that.
You're welcome. Yeah, of course. So let's get back to HDMI. Why don't we?
Now.
I know I've taken us off of the path. So
when we're looking at iPatters, not only do we have to make sure we have enough space high and low from the mask, that's just the beginning. Because remember, currently we have 3 high-speed channels: red, green, and blue. And not only, again, do we have to have the space, but all 3 of those channels have to line up with each other. So you wind up with 3 channels getting tested, and they all have to match in time. Now, when you're looking at TMDS, when you're looking at cable testings, there's a couple of things we look at. And they're skew. There's inter-pair skew and intra-pair skew.
Right.
Now, what is the difference between inter and intra, Adam?
Inter is inside and intra is outside?
No.
Okay.
Inter, I-N-T-E-R, is between multiple pairs.
Okay.
Intra is internal to itself. So, when you were looking at the cables, remember, we've got 3 feeds.
There you go.
When you look at the cable, we've got the 3 primary feeds. We're going to push the clock away for a second. So we've got red, green, and blue. Yep. Which is, hold on a second.
I was going to say, you got the clock. There you go. Got it? Got it.
RGB, and I'm actually going to try to...
We might need to switch our show over to a 12-volt car audio show, because, man, we get a lot of comments talking about, as soon as we start talking about the old times. Fate Tony's talking about the Alpine did that back in the 80s. So, anyways, yes, continue on. Get some water.
And so you wait till I take a sip to pass it back to me.
Of course.
So, we've got the 3 primary colors, and we're looking at the headroom, and by now everybody should know what headroom is. You want to have lots of space around that eye mask, but you also have to look at timing, meaning that transition is the same red, green, blue. Because if it's not, you're going to wind up with sparkles.
Right.
Or worse, no signal at all if it gets really bad. So, when we're looking at this, we were talking about interpair and intra-pair skew.
Yes.
Now, I'm going to do some very lousy drawings.
Okay.
Because I'm a lousy artist.
Is there... I'm sorry. Have we not seen your good drawings?
You've seen the best I can do.
Okay.
Which is still lousy. So... Now, this is a good example of intra-pair skew. Mostly because I'm a lousy artist.
Well, I was going to say, I don't know about a good example, but it is.
No, it is. It was not what I meant to draw.
Okay.
I was going to draw inter-pair skew, but since I can't draw an accurate reproduction of a properly twisted wire, we're going to discuss intra-pair skew.
Sure.
So when you look at this, you'll notice that the transition points are not all at the center line.
Yes.
And that's what you want to happen. Those crossover points need to be all down the middle, because that means that the upper and the lower sections are all, for lack of a better phrase, square.
Okay.
It's like squaring up a box.
Sure.
Yeah, you know, you check the measurements to make sure that each way is the same.
Yep.
That's the same thing here. So assuming all these crossover points are dead line down the middle, that means that our intra-pair skew is very low. This represents high inter-pair skew because if you look, because of my
Way
lousy
off.
drawing,
So now that's a timing issue, correct?
that is absolutely a timing issue.
Okay.
So what that means is one of the wires is going to be longer than the other wire.
Okay.
So the AC waveform will not be correct.
Now we see this a lot in our side of the world because when we get calls about a cable that's not maybe the best quality cable, or you know, something that's somehow, some way they've cut corners in the manufacturing of it, and that would cause this particular problem.
And it will generally come because the winding machines are not properly monitored
Gotcha.
at the factories. Now, let's talk about this in greater detail because this is just a single, one of the three conductors.
Right.
One of the four actually, but we're going to focus on the current HDMI specifications and the 3 high-speed channels.
Okay.
So we've now got 3 of these that are like this, and you've got intra-pair skew issues there.
Right.
Now, along with that, you also have to look at inter-pair skews. Now on those, the crossover points should not only be square on the center point, but with each other.
So this is intra.
This is inter.
Inter.
One cable is intra, multiple cables is inter. So these lines should be the same.
We'll pretend that they're the same, right?
We're gonna, well, this is actually pretty close.
It's a good example,
That's
right?
a good example of a lousy artist.
Sure, sure.
Now, when you have variances in these, and this is a good example, but let's say that this one right here was a little further off and more repetitive.
Right.
What we're going to have, if this is RG and B, you're going to have issues with the green feed not matching up correctly with the red and the blue. So we're back to timing issues. So not only do we have to worry about timing issues internal to each channel, we have to worry about the timing issues between all 3 channels.
So when we're, what does that look like? If we have, like, say, one particular channel like that where we are missing or we have the wrong timing on one channel, what does that look like?
This is the green channel as I've listed.
Sure.
You will wind up with green sparkles on your display.
Okay. Just because they're out of sync.
They're out of sync. They're not there at the same time because this is a clock. And by the way, that is the 4th channel
Yes.
of the TMDS feeds is a clock. And the clock's only job
Just to keep time.
is to tell everything where to be and when to be there. That's it.
Right.
And when those things are out of sync, you miss the bus.
Right.
And the more it's out of sync, the greater the chances of failure. So we are looking at multiple things here. We have to worry about, again, winding quality within a given setup. And we call it pairs, but it's really triplets because you've got that return.
Correct. Yeah.
So you've got to worry about that. Then you've got to worry about how they connect to each other. And this is not just the twisting, this is also how they're laid out in the cable.
So let's talk about, let's compare this to something that's more readily available for the average custom installer.
Okay.
Let's talk about Ethernet, because
Okay.
that's a similar. It
Well,
may
it
not
is.
have the three.
Well, no, it has
paired
4,
together.
but you only use 2 typically.
Correct.
And what 2 do you typically use?
For the data connection,
Yes.
you're going to put me on the spot with this, aren't you?
Yes, I am.
Hang on, let's see if I get it right. I know that blue is your power. Normally, it's green and orange.
Normally it's green and orange.
All right.
And green and orange are effectively the same twist ratio.
Right.
Blue and brown are not, because if you're doing anything ancillary, you want it to actually be slightly out of time so you don't interfere.
Right. So with that, if take that concept then and put it together with, take the concept of the twisted pair, four twisted pairs, and instead we now have, they're not pairs, they're sets in the HDMI world.
Because it's triplets.
So you have 4 twisted sets.
Yes.
One of them being the clock, and then red, green, and blue.
Yes.
Now in the HDMI world, you want all 4 of those to be the same twist ratio
Yes,
all
you
the way
do.
across. And you you want them to be as exacting as possible, exact as possible.
As close as possible.
As close as
now,
possible.
It will never be perfect because it's still human termination.
Right.
Meaning all 4 of these colors are manually terminated with solder to this head shell.
Right.
This is not an automated process.
No.
It can't be.
Right. Not yet.
Not yet.
Yeah.
So this is all manually done. So there's going to be slight variations, but that is built into the HDMI interface. And in fact, you mentioned the network cables. HD Base T understands very much how to deal with the timing issues between blue, orange, green, and brown.
Right.
That's why they give you either 568A or 568B option. And what is the difference between A and B?
So, if you really want to break it down and you really want to know the difference between A and B, you got to go all the way back into history and look at the fact that at the very beginning, somebody wanted some money and someone else also wanted some money. And so then they decided that, well, if that somebody's going to get their money that way, we want to make sure that we get our money this way.
But what is the performance difference between A and B?
Nothing. It's exactly the same.
What is the physical difference between A and B?
Just different colors.
You lead off with green on one and orange on the other.
Yep, that's it.
That's it.
Yep.
And because they're the same twist ratios.
Yep.
It does not matter. Now, I have seen some incredible arguments online about why 568B is just so much better than A. Because we re-terminated and B and it worked great.
You just redid your termination.
You just redid your termination and it's better now.
Now, not to start too much of a flame war on anything like that.
Yeah, we just did.
I mean, yeah, we did, but, you know, let's do that. Which one do you use, 568A or 568B? Go ahead and leave it down in the chat and leave it down in the comments. Tell us why you do it that way, if it's just because that's what you were trained on, or is it because you feel like you have a benefit to doing it a certain way?
Are you a Xerox guy or an IBM guy?
That's the names I was looking for before. So, Brent,
that's the advantage of being old.
So we've talked about what is TMDS. We talked about the fact that it's the transition minimized
differential signal.
There you go.
Signaling.
Okay. Now we talked about how we get from high to low or low to high because it's a voltage-driven signal. Because it's not amperage, it's not the actual draw that's causing it. It's not a change in that draw, it's the change in the voltage.
Right. Now, remember, this is just a light switch.
Right.
This is our relay for the car audio guys.
Yeah.
All this is an on and an off.
Right.
And just like any light switch and any light, when you turn that switch on, there's a time to go from all off, off, zero function, to on. And that is called the rise time.
Right.
Now, rise time is very important all across the HDMI interface because that covers EDID, I2C. That covers the TMDS. That also handles CEC. I mean, everything is based on a clock, and there's several clocks.
Which, in fact, we talked about that, not last episode, but the episode before, when we were talking about EDID, and we drew off another eye pattern, a similar eye pattern, and it is the same exact, basically.
Yes. You have to ensure, a lot faster.
Yeah, now you just have to make sure it gets there so that you get that eye pattern.
Let's talk about how much data you're sending down each one of these runs.
We're saving that for next week's episode.
You're killing me.
I know, but I have to hold on to it for next week's episode. I got something to talk about next week, right?
I thought it was my magnificence.
I know, well, no. Do you want us to have like a 2-minute episode? Wow. Anyways, how do the TMDS channels work together?
Well, currently, it's basically component video.
Yeah.
It's just component digital video. For years, we looked at RGB, a component cable. You had a red cable, a green cable, and a blue cable. And prior to that, we had VGA.
Right.
We had RGB, horizontal, and vertical sync. There was 5 conductors.
Right.
So, again, the 3 colors, then you had a sync for this and a sync for this.
Right.
Component took this sync and overlaid it on the green.
Yes.
Which is how Composite did it.
Yep.
Except it also added in
all the others together, yeah.
So that simplified that from a VGA terminal down to 3 RCAs.
Yep.
DVI, which predated HDMI, took that same component philosophy, or actually kind of the VGA / component, a red, a green, a blue, and a single horizontal and vertical clock.
Yep.
Now, DVI did not have audio. Could DVI have had audio?
Yeah.
Because audio is where?
Right now, it's on the TMDS lines.
Exactly.
Yeah.
It just was not built into the hardware.
Right.
It was not a limitation of the signaling process, just the hardware didn't do it because they didn't think, what do I need audio for? Audio is a separate feed.
Right. Now,
because it wasn't meant for the consumer.
So when you look at an HDMI cable, what you're looking at is a condensed component cable is essentially what it comes down to.
It's smaller.
Yeah, we just now have the ability to have full. I mean, right now we're technically right now we're up to 8K. It's not full 8K. We're not 444 60 hertz.
No, it's faux 8.
Yeah, it's faux 8. It's no one. Well, oh man, we got to come up with a new one, right? We used to be faux K. Now we need something different, right?
So putting that one on you.
Okay. Well, I'm going to pass it right on to them. So we'll let you guys decide what it's going to be. Okay. So and actually, real quick. Phaetonia has come to your defense in your art skills.
He's in desperate need of a life.
I was going to say, they say, Brent, abstract art has no defined condition. It is in the interpretation of the artist and not a copy machine image.
Well, I can promise you it was not a copy machine image.
And then the experts are saying they use B because it's pretty much the standard that everyone uses today.
And it is.
Honestly, it is. I mean, if you're using B, you're in a better position to make sure that if you come onto a job site second, usually the person in front of you has already put B in place.
I firmly believe in a corporate standard.
Yep.
I don't care what you pick, just pick, because I have dealt with jobs where one guy did an A at one end and they did a B at the other end because it was a different guy.
Yep. Yep.
And, you know, you and I both still, okay, sir, let's take a look at your terminations. But really don't want to go down the HD-based T rabbit hole today.
No, we'll hold on to that one for another time.
We're looking at, again, when you're looking at the HDMI, as we transition DVI into HDMI, all it became was a smaller terminal. They added audio and they added HDCP.
Right.
Now, HDCP does not have separate feeds.
Nope.
It's not even HDMI. It's another company that simply rides down the same road that is I2C or EDID inside of the HDMI terminal.
Which we talked about that
at the very beginning.
Yep, 2 episodes ago.
Okay,
yeah,
that's right. Voltage, EDID.
EDID, and now TMDS, TMDS, yep.
As we're going forward, again, right now we have 3 digital video channels.
Yes.
D0, D1, and D2.
Yes.
D3, which we pushed off to the side here, has been the clock channel. Now, this is what's going to get a lot of guys in trouble as we go forward into HDMI 2.1.
Right.
And why is that, Adam?
Well, the reality is, and we talked about this earlier on when I said that sometimes we have calls where people have a subpar or lower quality HDMI cable and they're having troubles with it. Well, now when we move into HDMI 2.1, and a lot of times it goes back to the twist ratio. So,
twist ratio and gauge.
And gauge, correct. So when you are looking at, let's say for instance, when we develop an HDMI cable and we go off to manufacturing and we get it made and we bring it out and chop it up and put ends on it and send it out from there. When it's made initially, it's on these giant spools with thousands upon thousands upon thousands of feet, all on one spool, and then from there it's drawn out to 3 meters, 1 meter, 15 meters, however long, and then it's cut. Now, here's the thing. Over that distance of thousands upon thousands of meters, what you have is if you lower the twist ratio on one of those channels and you slightly decrease the gauge of wire on that one channel, this is the clock channel, of course, the amount of money that you can save on that one, on those 2 very small changes, which per cable you don't make a whole lot of savings on, but over that long distance of copper that you have on that reel, you wind up with a cost savings of a dramatic amount.
Absolutely.
And so many companies out there have gone about and have done it that way.
Well, they'll take it a step further than that. We discussed how properly built, this is a 3-conductor system like an XLR.
Correct.
It is amazing how many manufacturers will skip the individual grounds
and share a
inside of that and share a ground. They'll take the shield, which is not correct, because remember in the early days we had an HDMI cable tester.
Yep.
And I think we've got 1 or 2 of them floating around here.
Yep, right back here.
That's the second gen, but...
Is that the second gen?
Yeah. This actually looks to make sure that all 3 of the conductors are there. If they are not, the system will show invalid or a fail, because you're not properly segregating the 4 grounds separate from a common ground.
That's the same one, isn't
Same
it?
one.
Okay.
So cutting these corners at 2-3 meters on 1080p was not that big a deal.
Right.
It wasn't right, but you generally didn't see failures, generally.
And in the most cases, you could get away with it. Everything worked
Right.
fine.
It worked.
Yeah.
Those days are gone. We are now at 18 gigs or 4x6.
Yes.
Excuse me, 3x6.
Yep.
We're moving into 4x6, and as stated, that's where this becomes critical.
Right.
There's a couple of things happening. When you look at TMDS, it's simply right now red, green, blue clock. Mm-hmm. Each color has its own carrier, its own car, its own truck. Mm-hmm. That is changing dramatically as we go forward.
Right.
The big change between HDMI 2.0 and 2.1 is how the data is transmitted. It is no longer going to be a separate red, green, blue feed and clock. It is now going to be aggregate feeds.
Yes.
So you're going to have the same 4 channels, but each of those channels is going to get its bandwidth capable combination of red, green, blue, and clock. Now, for retailers, this is a godsend.
Yeah.
Because when you have the 3 channels that are all independent, and there's a failure in any one of those cables or in the hardware on one of those channels,
Yep.
the system collapses. You take it back to the retailer, and they got to deal with you, and then they got to go to the manufacturer. What's happening now? Would you give me a overview?
Yep, sure will. Don't go too far, too far. Come back my way. There you go.
So now, each of these channels is capable of up to 6 gig in the interface, and 12 when we go to 48, but we're going to start at 24 because that's realistic for now. Mm-hmm. So each of these is going to give you RGB and clock in each one, and the reason they're doing this is because they can cheat big time.
Yes, they can. Now, I'll let you finish talking about this because you'll probably go ahead and cover what I'm thinking here as well. But let's talk about what that means for the installer once that starts becoming a thing.
It depends on your customer. Mm-hmm. And here's why. If you have, let's be honest, a fairly typical customer, all they want the thing to do is work easily, work correctly. They pick up their remote, they press a button, and what's supposed to happen happens.
Yep.
They're going to get a picture. This is going to make your life actually better.
Yes.
And here's why. We're going to make some assumptions here, and I think these are fairly good assumptions.
Yep.
We're going to assume that the cables are not all capable of 6 gigabits. That's a fairly safe assumption for probably, not counting ethereal home theater cables,
Yep.
80 to 90% of the products out there.
Yep.
So let's say this one's good for 4, this one's good for 6, this one's good for 3, and this one's good for 4 also. What is that combined number?
Let's see. 4 plus 6 is 10, plus 3 is 13, plus 4 is 17.
Now, it's not 24, but it doesn't matter because the system's going to auto-regulate.
Right.
Meaning it's going to basically look at all these, say, okay, I'm getting 4, 6, 3, and 4. So what I'm going to do is I'm going to produce a picture within that available range.
Yes.
And HDMI in their infinite wisdom for testing.
Yep.
And by the way, our reports of the CEC being out and available turned out to be a tad bit premature.
Again?
Yes, even though it has been released, all they really did was say, that one that we gave you a year and a half ago that really wasn't complete, we're calling it official. They still are not doing eye pattern testing.
Gotcha. So we
don't really have
nothing's really
a CTS.
There yet. Okay.
Right. Nothing had changed except that they were tired of getting yelled at.
Which is why we still use DPL. And DPL is they
fully
are
eye pattern and
yeah, I mean, they're a governing body of some kind that we can actually go to and say we need to make sure it meets these standards.
Yes.
Yeah.
So, but we're going to get back to doesn't quite meet the real standards, but still meets the certification standards. Mm-hmm. Here's what HDMI is doing under the current lax CTS rules.
Right.
Each of these channels offers 8 different variations of equalization. All each channel has to do is pass on 2 of those 8 equalizations. So it doesn't matter how much data actually gets down that channel, as long as it passes on 2 of the 8 EQ curves. That's it. Not the 8, not 6, 2 out of the 8. So you may again get 4, 6, 3, 4. Your TV and your source will auto-compensate. It will still give you that happy 4K or 8K number on the TV.
Right.
You may not be getting all the data, and the way HDMI works now is effectively if you get 70% of the data, you get a picture.
Right.
Now is 70% 100%?
No.
No, and what do you not get?
Well, what you're going to wind up running into is actually very similar to the days, well, no, I say days of, it's still here today, stereo, hi-fi stereo. When you have an okay quality component, an okay quality cable, an okay quality speaker, you're going to get okay sound. Then if you, of course, upgrade from there to a good quality or high quality player, high quality cabling, and high quality speaker, you're going to get high quality sound.
And where you're going to see it, when you look at our shirts, and you guys are looking at us typically on YouTube, on a small picture, on 720 or 1080p.
Right.
You're not really seeing what our camera's capable of seeing.
Right.
Because it is a 4K Blackmagic, and boy, are they awesome.
Yeah, we're very happy
But
with
when
it.
you look at this shirt, it is all, in theory, one color of red. But it isn't seen as one color of red. Otherwise, there'd be no field of view, no depth, no detail.
Right.
70% does not give you as much depth, detail, and knowledge as 80, 90, or 100.
Right. So things are going to look flat.
Right. You get a more, even though you got a picture, and I love this part. Well, digital's digital. It either works or it doesn't work. No, that's not true. Because it's all about thresholds. Once you make the threshold, you have a picture. Now, you talk about a flame war. I have just created a flame war.
I was gonna say, do we want to? Here's the thing.
That is definitely gonna. There's bazookas coming out.
Actually, I'm gonna pass this on to everybody watching today. What would you all think if we were to go on to say Reddit or the AV?
Good, no.
But hear me out. We'll go on there. We'll remove any names of anybody on there, and
I've been down this road. It's not pleasant.
The rumors of what HDMI is and what it isn't, and we'll do a response to it. We'll do a response here on the videos. I think we should do that. If we want to start something, we'll start something.
I'm 60 years old. I don't want a war.
Faytonia is saying that the new Marantz and the Denon receivers have a cable testing function.
Yes, they do.
Built
By
into
the way,
them.
I did 77.0. What is the current
Is it 3 or 4?
I don't know, but by golly, I liked it.
Well, you did it just over the weekend, right?
Yeah,
you got one set
liked
up.
it.
Yeah.
And the Sony 295 with it.
Now, is that testing function? Is it a 2.1 testing function, or is it's a 2.0?
No, it's the look 2.1. The reality of 2.1 in the field is tiny.
There's not a lot out there right now.
Somebody is going to be shipping, and you and I discussed this in one of the news articles a month ago.
Yeah.
I think it's D&M is shipping a 2.1 product this quarter.
Yes.
Onkyo, Integra, Yamaha, and Sony are looking at next year.
Yep.
I'm going to be honest with you. I love D&M. You know, we use their products. But I would not buy a first gen 2.1 product. I just wouldn't.
Yeah. Now,
I don't know that's going to be fully firmware upgradable.
Yeah. Once things, well, just like when 4K came out, we ran into that
Well, a good
problem
example is
originally.
the job I just did. He had a AVM 50 Anthem.
Yep.
Oh, I really should have set myself up for the future. 5 years ago, you couldn't.
Yeah.
There was nothing you could buy.
Yeah. Because
That's
nobody knew.
going to take you to where we're going.
Yeah. Nobody knew.
So, if you want to buy it and you enjoy it, buy it.
Yeah. All right. So now Faytonia is saying that you'll lose lossless audio, which that would make sense. Let's talk about that. What may be the first thing to go? Let's say you've got a really good cable, but it's at like 95%.
Something's got to give.
Something's got to give. Maybe the audio could be the first thing that's give. That way
but
the
remember,
video.
digital's digital.
You know. Well, well, here's
It's just
the thing.
ones and zeros.
Well, here's the thing. So you lose lossless audio, but when I actually did the math on this before, if you really break it down, in fact, I'll have to find the email, and for next week's episode, help remind me. I did the math on it.
I love you say that to me.
Much, yeah, right. About how much data Dolby Atmos versus Dolby 5.1 uses. And when you compare the two and then compare it against the video, how much bandwidth the video is using, it's
insignificant.
Fractions of the amount.
Now, it's not just the data, though, because you also have to be able to support the additional intelligence down the EDID channel for that object-oriented audio.
So it's not even the, well, and that's still going down the TMDS line. All that information is still heading down there. Now, the EDID is just saying, do you have the ability to decode what I'm about to send you?
Well, there's a lot of additional instructions set up in the EDID for Atmos outside of.
Now is that on the current stuff, or is that on 2.1?
Yes, and that's why Atmos can absolutely work backwards.
Gotcha.
But you still have to have those capabilities.
Right.
Remember, Atmos is in 2.0 products.
Yeah, correct. I just didn't know if they were upgrading something additional on top of that. eArc, of course, is going to have it.
But that's in 2.0 also.
Yep.
What will change is dynamic HDR.
Yeah.
And that really pushes the EDID out there, because there's a whole lot more. That's why you're going to start seeing EDID over other channels.
Right.
Because they've run out of space.
So, Brent, let's talk about, we've kind of covered TMDS pretty well. I want to save some of the stuff to talk about for next week.
Oh, there's some good stuff.
We got some good stuff to talk about next week. Let's go ahead and jump into our news information about what's going on in the industry. And then we'll go ahead and talk about
the tech call first.
Do the tech call first? Okay. So this was really interesting. We had a call.
Bizarre.
And honestly, we don't have an answer for it just yet. We have, between the three of us, we think that there's
some ideas,
something.
but until we hear, we're going to have to call him back. And
we'll have to track him down. If you're watching this video, unfortunately I forgot his name. If you are watching this video and you have this problem, give us a call. You'll see down below, if I hit this button here, you'll see the phone number down there.
In front of him.
Yeah, there you go. Give us a call at the tech support line, 386-492-8584. And give us a call and let us know if you're running into this problem as well. We're very curious about it. But here's what he's running into. So he has a FiOS cable box, a new FiOS cable box, which is kind of like the Roku, where it picks up on the EDID information of the next device.
Or the Amazon.
Or the Amazon, where it can just go ahead and program the remote automatically. Now, he's going into one of our extenders. It's
a more
the
basic
entry level. Yeah,
right.
it's the entry level extender with the DID switches
selection.
on it. Yep. From there, he's going into a Samsung. And we know it's a Samsung because he turned off AnyNet. He specifically said AnyNet. Yes. Now, with that, he's going from the FiOS through all of that, and he's not going through any audio system whatsoever. He's just going directly to the TV. Now, with our extender, it has a loop out, and that hasn't been plugged in. And when he goes into the FiOS box to program the remote, there's no way, at least from his understanding, there's no way to program that remote separately than what the EDID information is that the cable box is receiving back.
It's attempting to take you out of the equation.
Correct. So from there, what it's doing is it's saying that there is a Integra receiver in line on that connection.
So
now, it found the TV for power, but it didn't, for some reason, it picked up as an Integra audio system. When he bypasses the extender and goes directly to the TV,
it works perfectly.
It works perfectly fine. So for whatever reason, our extender is saying Integra.
And I have no idea why.
So talking with Stuart about it to see out what could be the problem with that, and kind of discussing it with him, he and I kind of came to the conclusion that there's a possibility that we have been borrowing. We'll have to get with the engineers, of course, to find out for sure that we are borrowing the EDID information.
But the EDID information we're using is generic for 5.1 or 2.1, and there are generics for that.
Maybe Integra is using the generic code for their own. Which we don't know yet. We're looking into it and find out for sure. We'll get back to this on
that was a bizarre
next week's episode. We're going to try and contact him and find out for sure.
We do not want to sound like any control company out there that every time you call them, that's the first time you've heard about this.
Yeah, no.
No, that's really...
Now, here's the thing. What was the first step that we asked him to do?
I wasn't here.
Well, no, you were here. This was we went ahead and had him
reboot.
Yeah, reboot. We had him go ahead and unplug all the copper connections.
All the copper connections.
Yep.
And gave him a specific reboot order, which is HDMI cables first.
Yep.
Then the coax cable, because the coax carries voltage.
This is plugging back in.
Right.
Yes.
All copper is disconnected.
Yes.
This means display, extenders, and source. Start with HDMI cables, then coax cable, then power from the display back. So the last thing that gets powered up is the cable box.
Right. So when we gave him that instruction. Now, here's the thing. It's a very real possibility that that fixed it.
But we don't know.
But we don't know because he hasn't called back yet, and we'll find out for sure, which we'll let you all know next week about that as well. Now, Phaetone is actually saying maybe the extender has a similar SBC as the Integra product. Yeah.
And it's quite probably, when you look at Integra and Denon, both of those companies actually adhered very closely to the HDMI, EDID, and TMDS specifications.
Yes.
Some Apple, Roku, Amazon, they play a little bit
Fast and loose.
Fast and loose with Apple. Apple. I didn't say that.
Huh?
Yeah.
It's a certain fruit, right?
Yeah, it's a fruit. Yeah, it's a fruit. They play fast and loose with the fruit.
Uh-huh.
And it has created some interesting, now, they have gotten much better.
Yes.
Our calls in reference to that have dropped dramatically. Have gotten some calls recently about LG panels shutting off, which we believe is control error detection. Remember that CED, where it counts all the errors and then just shuts the system off till you do a full reboot?
Yes.
We used to get a ton of those. It dropped out, and I got a couple this week.
So there may be something going on where that's coming back.
Firmware, yeah, we don't know. And LG firmly believes you need to use it. Sony, Samsung, and the others do not.
Right. And that's usually where we run into with the active cables and the extenders.
Yep, and extenders, yes.
All those types of connections.
Now, I have some very happy news because I'm excited about this one.
Is this the same news that I just pulled up?
Yes, it is.
Okay, you go ahead and give the rundown for it. I'll get some of the details.
One of the best shows to go to, in my opinion, is ISE in Europe. Now, for up until this year, it has been in Amsterdam, which Amsterdam in February is not the best place to go.
It's very cold.
And wet, and windy, and drizzly. It's kind of like going to London.
Yep.
But this year, Barcelona. It's like woo and who until COVID. Now, yesterday they decided that February was just too soon. And I am happy that they made this decision. It has been moved to June.
Yes.
So hopefully by that point, if medical science catches up and gives us some alternatives, it will be safe to go.
Yeah.
It is an awesome show to go to. CEDIA works very closely with with ISE.
Yep.
And what you're finding is, in the States, you have to go to Infocom, CES, and CEDIA to really get a wide breadth of what's available.
Yes.
ISE is really Infocom and CEDIA with a little bit of CES tied in. So you got commercial, residential, arena, I mean, just incredible.
Right.
Not as signage and lighting focused as, say, Infocom for signage and stuff, but for audio and video, phenomenal show.
Yeah. And it's definitely one, if you get a chance, it gives you an excuse to do some traveling abroad and whatnot. It's a great show to go to. So that's really great news. Specifically, they're actually pushing it off until June 1st through the 4th.
Yes.
And which, of course, is in Barcelona this coming year.
And Infocom, unfortunately, is right after that. So it's going to be...
They were going to do it this year. They were going to have it in... Well, no, I'm sorry. They did have it in Amsterdam this year. And then next year they'll have it on June 1st through the 4th in Barcelona, which...
On the Mediterranean.
It'd be a little warm that time of year over there for that,
right? That's the thing. Barcelona does not change temperature that much.
Okay, so it'd be kind of nice and
it's spring in the Mediterranean.
Yeah, that'd be very nice. So, with that said, everybody, that's our news for the day. It's our information we have for you for the TMDS on HDMI deconstruction. Come back next week, next Wednesday, where we'll be talking about HDMI deconstruction 4.2. That's the last of our series where we're going to finish up talking about TMDS. We're going to be talking about what happens when TMDS doesn't work. We're going to be talking about how to fix TMDS when it doesn't work. And we're also going to be talking about some of the other stuff that I stopped you from talking about next week. So we'll get into that as well.
I don't remember what that was now.
So with that, everybody, again, as always.
Don't forget.
Yep. You can contact us here if you have any questions, whether it be tech support, you want to ask us a question about the design of a project that you have or anything you have going on.
Please.
Yeah, do it ahead of time. Early. Yeah, because we've got some stuff to put out there for you so that you don't run into issues while you're out there on the field. And plus, it's always helpful to get a second person to look at it, do that sanity check on it. So,
which, by the way, we do to each other.
Yes,
believe me, don't think that we sit in here and think we're gods.
Well, and honestly, it kind of becomes kind of a heated debate between all of us here whenever we get involved with a project. So, with that said, everybody, you can contact us here on tech support at 386-492-8584. It's here on the screen back here. It should also be down here on the bottom of your screen there. You can also contact Brent directly at 866-839-9187, extension 2203.
And the business phone follows my cell phone.
Yes, it does, and you're available
8 a.m. to 10 p.m., 7 days a week.
There you go.
Except for video surveillance calls.
Yep. Now, with that said, as always, everybody, thank you so much for watching the video with us today. A like and a subscribe and a share and a bell notification. We're trying to get up to 1,000 subscribers, so definitely get that information out there for everybody else if you can. We'd be really appreciative of that, to meet that goal. From there, thanks again for checking in with us. We'll see us next week, on Wednesday at 3 o'clock Eastern Time, as always.
And tell us, we made some changes in the past couple of weeks with cameras and controls. Give us your thoughts. Is it something you can see? Does it matter? Mm-hmm. Do our cute little bugs in the front there?
Over on this side, yeah?
Yes.
Yep, that little thing there, yeah. It does things, too.
Yeah.
Let's see if I can get it to work right.
Yeah,
there it goes. See,
we're trying to
do some fancy things, right?
Yeah. Let us know. Also, if you have any ideas for shows that we haven't discussed. One of the ones that got passed up for the HDMI deconstruction is Tools of the Truck.
Tools of the Truck, yes, which we are still doing, and we are still asking for more of your sheets that you have.
And we've got some really good ideas.
Yeah, we did. Now, we're asking for tools that you think are tools that you have to have. We're also looking for tools that are kind of out there that you wouldn't think you should have, but have saved your butt in the field a couple times. Let us know what those are. And then, as always, we're doing the truck as well, so we're going to do a truck competition with it.
I would also, for those of you who are not, I would encourage you to get signed up for Integration Pros. It's a great resource.
Yep.
And give them your $5 a month to keep them working.
Yep. And of course, our news came from CE Pro. We want to thank them very much for, of course, keeping all the stuff together.
And hope that Julie enjoys her retirement.
Yes, exactly. So with that, everybody, as always, thank you so much for checking in with us. Hit that like, subscribe, and share button, and hit the little bell notification. And as always, Brent.
Don't cut your wires too short.
Reboot early.
Turn off CEC.
Reboot often.
And I think that's it.
Call tech support.
Oh, yeah. That's these numbers right here.
Yeah, those numbers there and the number down there. I'm Adam.
Have a great day.
We'll see y'all next time. I'm going to